Alright, well, so you guys keep asking about the homework and you don't want to do it. La-di-da-di. Okay, I'll make you a bet.
Okay. I'm in bed.
I'll gamble your homework. I'll gamble your homework.
Okay.
7th grade is very loud. Oh, no.
Yeah.
Here's the bet. If you win this game, you don't have to do your homework. Here's the rules. If it is very weighted. If we get an even number, we're gonna go right. If we get an odd number, we're gonna go left. Okay.
Is there an actual way to win this game?
We are going to play 3 rounds.
I think this is our chapter thing. $10 says that this is part of our chapter and it's all fake and we can't win.
Bet money. Right here, right
Roll it up.
Can you throw it?
Don't throw it like close to the ground.
So what do I have? What should I get?
Just roll it. Just roll it.
We can't make
Even
roll
goes
it.
right,
What the bet
odd
is.
goes left. Roll it.
We don't know what we don't
I'll
know
roll it.
$10 says I'll land this.
If we
Two.
lose, then what punishment do we get?
Steve, roll.
I don't know. So wait, if we get 5, does that mean we have to do 5 more questions?
Odd.
We have to land on
Can
the
I
star.
do it?
I'm gonna box Jacob.
I'm going after Nitin.
4.
Right. Game's over. You lose.
How? How?
Because it was 3 rounds. That's the game. Let's try again.
Nitin.
Levi, you roll.
Nitin. Hey, Mr. Hudson, you go first.
Is this a waiting? Yeah, Mr. Hudson goes first.
Right. Even. Right. Levi?
Oh, there's no way to win.
That's sort of.
Don't throw it from too high.
Oh, there's no way to win,
So
right?
you'd have to get
Is this a waiting queue?
6. We go right.
But you'd have to get another. We have to get another even, or else.
It's a 1 in 12 chance.
Guys,
So
we have to land on the
You
star.
can either get to land on the
We
star.
have
That's
3
your
rounds.
win spot.
that's
It's
impossible.
Mr.
Roll.
Hudson, you
Oh,
go
I figured
first.
you had to leave on.
Oh, it is impossible,
I
right?
said this when we started. He's not going to let us know.
Sit
our
down.
homework.
Sit down.
Oh, you can't go like that.
Well, that's dumb.
Now,
What if I let
sometimes I don't like teaching you guys because this would be a lot more fun with a class of people that aren't quite so smart.
What do you mean we're dumb?
We are.
Yeah.
Because you guys quickly have determined it's rigged. That's not really rigged, it's just math. So who wants, excuse me, who wants to explain why I'm an evil, not really genius, I'm an evil, moderately intelligent person? Thomas? Yeah, come on, yeah.
You could write it like a teacher, I guess.
Because
I'm worried though, because you said the probability.
because there's an odd number of them, and we go first.
Oh my god.
Then
It's not even about we go first. He doesn't have a turn at all.
he doesn't go.
It's just whoever rolls the die. It doesn't matter who goes first, but yeah.
There are 3, and there's 1.
Oh, we could land on the star to win.
There's 3.
Well, I know we had to
No
get
matter
more
what
than
you
2s.
do,
Yeah, I
you
kind
can't
of thought
do
we
it
had to get
because
like
it
a
has
5
to be
or
an
2.
even number.
Yeah, it has to be an even number.
You're still holding the
Nice. Wait, why did we just don't start on the star? Or do you have to?
You have to.
Try to here.
I thought if we
Can I
got a
explain
5, you were going to make us do 5.
Sure, I'm kind of nervous.
That's why
yeah.
I didn't
Okay.
You said the probability is 1
Yeah, but
12.
we have to land on one of these.
Yeah, that's
Okay.
what I was thinking initially, but then I was like, nope, it's the star.
Okay, so
What is the negative 1 to 5 over 2?
so you start
Points,
here.
like,
Oh yes, we'll just do that there.
We got 2
Then
points.
you can either
1 point and counting the
go
rating.
forward,
The 4.
forward, or back. Lee, F.
does it matter whether I go forwards or backwards?
Not really.
Not
Either
really.
way,
So
you're
then,
not getting on the
From
star.
here, you can either go forward,
Now it matters.
forward, or back.
And then from there,
Why are you making a tree turn?
it ends up not mattering.
He wants
You'll
to.
never land on the star.
You can
Okay,
sideways.
so there's no. Here you can either go forward or back.
You're backwards.
On the star there.
Forward should always be right.
Here you can go
We got hit with a 2.
forward or back, forward or back.
So let's discuss
Wait,
this. I got a more complicated problem. I think we all get like the reason the star doesn't work.
Yes.
So a more complicated question. So these numbers are point values, right?
Yes.
If you were to play this game, say 10 times, right? 3 rounds is every time you play the game, it's 3 rounds. We've now figured out you can't land on the star, right? Great, wonderful, awesome. Any other issues? Because hold on, so we're gonna play it 10 rounds, and really my question is gonna be, what would you expect your end score to be? But do we see any other issues with our game?
Can't land on 5.
We cannot land on 5.
And there's more of a chance we'll get -1 than 2.
So we today are going to develop some strategies for determining how to predict the expected outcome of a given situation. It's jazz. It's not a video.
Stop staring at YouTube during class, Mr. Hudson.
I'm not staring at it. I'm playing it so my kids can work on a test and not listen to Mrs. Pettigrew across the hall.
Oh!
All right, head your notes.
Miss Pettigrew
Head your
feels the
notes.
same way about you.
Oh, I know she does.
No, she does not.
See, she comes over and tells me.
Yeah, she also told me when I released my last class early because I couldn't see the correct schedule when I went.
Actually, it's on mine.
Yeah, it's gone over my territory.
What we call this in math is expected value. What we call this in math is expected value.
I was expected to have value, but look where I am today.
So when we design a game of chance, if it's really a game of chance and is not biased or weighted in any direction, all outcomes should have even possibilities, such as rolling a die. Each side has an even possibility of happening.
But it's weighted.
Or flipping a coin. Each side has an even chance of
But
happening.
it's weighted.
Everything's weighted. Otherwise,
I have
it
a
doesn't
wager for
exist.
this moment.
Exactly.
Everything has mass, right?
It's wigged.
Everything is
The
weighted.
die is wigged.
I said weighted.
So there's hair on the die.
When he said on it, I was like,
Hey, by the way, next time you guys end up using my computer, Mrs. Smith should not be the person bringing it back.
Wait, who?
It should be one of your guys' responsibilities.
What happened?
They use my computer during form, and Miss Smith brought it back. Like, that shouldn't be her job. It should be you guys.
Sorry, it was.
You don't need to apologize. I'm just saying, like, next time, why don't you bring it back? Because she was, like, slightly annoyed that she had to bring it back. Well, she was actually kind of annoyed that you guys used my computer as opposed to, like, getting an 8th grade teacher. I don't really care because I have it in there for 7th grade form. Because it doesn't connect to the projector. Yeah, Chromebooks don't have the port out. All right, so let's say we're gonna play this. We start real easy here because we can go back to that game in a little bit, but I don't know exactly that we'd be able to figure this out. So talk with your team. We're gonna play this game 10 times, and then we're gonna end up playing it 30 times, and then we're gonna end up playing it 100 times. What do you think would be your expected value for each amount of times that we play? Talk with your group right now, or like write it on your paper, figure it out for that spin. Then you get that figured out. You think it's too easy? Move on to 48, and we're gonna do 4 spins versus 100 spins, and extend this conversation. And hopefully, I'm guessing this lesson's gonna go a little bit faster. But take like 2 or 3 minutes.
Or just sit on one of them and put the other on the side.
Oh, if you play this game 10 times, you're probably gonna get it. Not.
It's like $2.
Okay, so every 2 times, you're probably gonna get $4. Multiply 4. Multiply 2 by 5, so 4 by 5, you get $20. Basically, you double it.
What do you do?
So
I am confused on your logic.
50 would be 100, 100 would be 200, and 10 would be 20.
Yes. Wait, 10 would be.
Yeah, what is?
No, yeah, it is. I'm sorry.
My God!
I'm so confused.
That's what P means!
It's not the probability order.
No, he knows this. It's just soccer.
No, I actually didn't know what that meant.
So, one of you guys stole my stool. Or apparently last class they stole my stool. We can determine the probabilities, right? And the probabilities is out of all the times that we do this, what fraction is going to land or is going to be predicted to land where we're at. So if we say half of our spins, or in the first case, 5 of them land on 0, well, 0. And if 5 of them land on 4, as you guys all figured out, we would expect to get $20 after playing 10 times. 30 times, well, we're just taking the amount of times we already had, and I heard you through conversation saying just multiply by 3, and we're going to get $60 from 10 to 30.
Oh, I thought that was 50. Yeah.
No, from 10 to 30.
Santi, what are you doing?
I
Does it
read
say
the book
50?
and the smartboard wrong.
Like sometimes this ebook and the textbook disagree. Does it say 30 or 50?
No, it's the 30. I just read both of these wrong.
And then 100 times, we would obviously take our $20 from the 10 times and just multiply by 10, and we would expect potentially $200. So this is how you can determine what fair games are worth it or not. Now you have to assume that nothing is rigged, quote unquote. But if this spinner actually operated fairly, and if it would relatively match the expected value, let's say you can buy a bulk amount of tickets for a discount, and you determine the expected value. So like if a ticket was $2 versus if it was $3. Like, well, if it's $2, it's pretty much you're expecting to get back what you put in, right? It's going to take me 2 spins to win $4 if my expected probability happens. But if the ticket's $3, I'm not sure about playing this game because it seems like I'm probably going to lose money, right? To buy 2 tickets, I spend $6. I'm going to win 4 regardless of winning. I still lose $2, right? Are we kind of with me there? So we look at this spinner. Use that skill set to determine the expected value of 4 spins there and 100 spins there. This spin.
This reminds me a little bit of. I'm drawing an area model. I'm not doing a tree chart with 100. Isn't that an area model though?
I mean, sort of, but not really.
Shut up.
Also,
what
to have 3, wait, on 3 different spins, right? You spin 1.
Okay.
And then you need 3.
You're gonna get $104 for 4 spins. So you just take the same thing for every 4 spins. You get. For every 4 spins, you get $104. So then you take that, you multiply it by 5, then you multiply it by 5. So no 4.
Probably. So 1/4.
Now, this won't make sense unless you're in my brain, what I wrote. What I hear you guys doing is saying, in 4 spins, 1 of them should land here because it's got a probability of a 4. Right? What if I ask you the expected value of 1 spin?
0.
That's the thing most probable. But let's really just think mathematically. So you're going to say that the expected value of 4 spins, I'm going to go ahead and we're going to make up some notation. So expected value of 4 spins, you're saying is 104. So supposedly, if I extrapolate that back to 1 spin, the expected value of every spin is 26. Here's how we get there. The expected value of a game, and I forget if their formula covers this or not, is the probability of the thing that we're looking at and then that thing, plus the probability of another outcome times that outcome, plus the probability of another outcome times that outcome, plus we just do this until we take all outcomes possible and involve them. So here, the expected value of 1 spin is 1/4 of 4.
So this is
Plus
$25 a ticket.
1/4 of 100. You're in my head. Plus 1/2 of 0. Please write that out.
I did.
Which means if you spend less than $26 per ticket, you should come out on top. You should win. By expected value, you should win. So we're not saying you can actually win $26 in one game. That can't happen. What we're saying is extrapolate it out. Every event that, like every time you spin, you're supposing that you're going to net 26. Net, right? Yes, we're averaging it out. But it can't actually happen. So that's, and I don't know if I'm actually using the word extrapolate right, but like we're taking something that can happen and talking about it in another way that can't necessarily happen. But then if I take this and I say, what's the expected value after 100 spins?
It's 200. It's 2600. Yeah.
You multiply by however many.
Play this game 4,000 times when.
So if it was like $25 per ticket or 100 for 20, shoot, I'm buying 100 tickets and we're going to be here all day, but I hope that I should net 2,600 at the end. Well, I should win 2,600, which whatever I had to pay, I would then like net the difference.
If it was an actual carnival game, you'd have like 0, 4, 0, and then.
Yeah, a tiny sliver of 100. Yeah, because they're gonna try to make it not happen, even by probability.
And then like once you get the 100, you gotta spin it again. Then you can only get the 100 if you get the 100 twice.
So that's what they show you right here. Right. Of this one. So take a moment. What is the expected value of one round on this spinner? Hang on to it. Don't tell us who dies at the end. This is something I've had to start using with my 7th graders when they like start trying to say the answer. Like, he dies at the end. That's no one likes that person, right? At the movie, no one likes the person who just shouts out the answer.
No, wow, that's a cool fact. That's a fun fact. I'm getting a calculator. Fractions are hard.
Wait, it was 45, you want to win 360?
Okay. Stop. You're invading my mental space. You're interrupting my learning experience. Stop interrupting my learning
Why are you
experience.
standing over here? And why are we smacking this calculator?
Because they want to interrupt my learning experience.
I thought you wanted me to interrupt your learning experience. I thought that's why you kept saying it.
What's 3/8?
This is not.
20.5, 70.
Point
Why was this
37.5.
with this?
It's wrong. That is incorrect.
37.5.
Because 0.125 times 3. But if you're talking probability, it's 0.375. Because you don't use the percent. So, but it'd be 37.5 if you're talking the percent.
Why did I write 37.5?
Because you're thinking in percents.
That is terrifying.
I don't know what that
I
was
think
about.
that's verbal graffiti.
He always does that. He always did that. He walked me down to my bus every day.
What's the probability of 45 degrees in the circle? 1/8.
I did it.
You lose money.
Compare that to 90, right? That's the easiest thing to do. You know, 90's a fourth. So then this is 3/8. So easy ones are we should have a quarter of 6,
There's
a
an easier way to do
quarter
this.
of 2, 3/8. I don't know why you're using a calculator. Hang on just a moment.
Because I.
And shh, hang on just a moment. Sorry, that looks like a B. This is a 6. We don't need calculators. 6 fourths, 2 fourths, negative 15 eighths, negative 2 eighths. Oh yeah, plus a negative for sure. Double 12 plus 4, right? 16 eighths.
There's an easier way.
Plus, I will never believe you when you're holding a calculator.
Negative.
Okay.
Take away the calculator. Was it easier?
Yes, it is.
No.
Negative.
I just thought of it. I didn't use it.
What's that actually tell us?
Lose
Lose.
money.
Less than half
There's a
percent.
negative net value.
It's even less than half percent.
Yeah, you're losing.
Supposedly every spin you're gonna lose 12.5 cents.
Explain the half.
This isn't real, right? This is not the actual expected value because that doesn't make any sense.
It doesn't make any sense.
That's
So
No, it doesn't.
this
make
is
sense.
like for 1. So we could say after 10 spins, I'm gonna call you.
I
You
want
just have
to
to
spoil
wait
the
your
movie.
turn.
Look at that face up there. He's
Or we could-
stealing her money.
We could even just say after 2 spins, we expect we've lost a quarter.
If he's paying you $2 to do 10 spins.
So we don't even know what the ticket price is, but even if this was free, we have to give them money. Right on the negatives, we have to give up money.
But
Even
yeah.
if this game is free to play, we're likely going to end up paying them.
fair.
Right? I mean, you can say like whatever, like there's probabilities involved.
Free
I mean,
spins.
you could actually set up a game that is in favor of the other people, and that won't necessarily happen. Now, if we trust expected outcome, it would happen, but it all depends on if you think the math would actually happen or not, or if you got magnets hidden under the table. Okay, now go ahead, Satya.
So
So let me capture it, and then you can do whatever.
I should buy a roulette table. Don't put that at the
I'm not playing your real
I could have just done this, like cut it in half, and then make this -7,
No, you can't.
and make this 8.
It's
Find
not a
expected
half
value.
chance. It's not a half chance that you lose 7.
Foolish boy.
Wait, is that a
You're more
shot?
likely to lose 5 more often than you lose 2.
Could you use it?
No, because you don't lose 5 and 2 at the same. You can do the 8 on the left side, but that still doesn't work if we do multiple spins. I mean, like we will win 6 as often as we win 2.
Yeah.
Right? Those are equal. So the 8 we could argue. The 7 we can't. You will lose 5 more often than you lose 2.
That doesn't even get you the right answer.
Dude, I like your
What are you
creative
doing,
thinking, but I
son?
need you to analyze, is this actually true? So here's the issue with what just happened. Shh, stop. Sit down. Here's the issue with what just happened. You weren't paying any attention to what we were doing. You came up with an idea and you didn't even check yourself. You just wanted to come to the board. That's like, you need to be better than that. You are better than that, but you're not holding yourself accountable to it. You need to check through in your head, does this actually make sense? Instead of just saying, can I come up, can I come up, can I me. Like, check yourself, man.
I thought like if you add them all together, it might be the same thing.
If I ask you the question, will you lose 5 as often as you lose 2? You would immediately tell me, no, this is the least probability up there. So these aren't the same.
But
You
if you
can't just
add-
put them together.
Isn't that? But
No,
when
this
you
happens
average,
more
add them
often.
together.
No, it doesn't work. You're breaking rules. You're saying that this thing is equally as likely as that thing, which it's obviously not.
But when you
This
add-
thing is 3 times as likely. Now, if you want to do what you're trying to do, you could do that and make the regions the same size. You have to create equally portioned regions before you can go down a road like you're trying.
So once you do that, and then you, so
But
it would,
still,
so
negative
it would
5 is not
work
as
with
likely as
6
negative
and
2. These 2 wedges could be combined together then, but not like. Still, that only makes me lose 2. That only makes me lose 5. I never lose 7 at the same time, which is kind of the issue with what you're thinking.
Okay.
Now, if you extrapolate out to like 1,000 spins or something,
Yeah.
then we could like argue depending on how you actually merge the numbers. But I don't think we'd put them as a 7. We'd like average them out. We'd say what's the average of losing 2 and losing 5? It'd be like losing 3 and something. Yeah. Rich.
I didn't actually have. I was just trying to make my hair stop being in little pieces.
Okay, so to take a moment on what Satya had said, just to make sure people understand, because we just said that really fast. If I try to put these together, this section still belongs to the -5, but if I want this to be one section, I have to average out the outcomes, which is not -7, it's -3.5. Because we don't add them, we average them. So if you really wanted to merge this entire section, It wouldn't be -7.
It'll be negative
It'd be
8.5.
3/8 of, well, it'd be 3 parts -5 and 1 part -2. And yeah. So I think we would do -17 divided by 4. And that would be the value of that entire region if you merged them.
That hurt my brain.
Well, you're the one who took us down that road.
Yeah, I thought it was words.
Next time we don't let Satya drive.
Didn't even get the right answer.
You find out.
All right.
You find
I
out
don't
now.
know. I don't know.
Oh, it's just a little bit like crap.
Double spin is a new game, kind of like the 1-on-1 that we were discussing with basketball. So a player gets to spin twice, but wins only if the same amount comes up both times. The $100 section is an 8. What's the probability you win? I don't care how much you win. What's the probability you win anything? Oh, try this. You cannot already know it. There's absolutely no way. Use an area model. Figure out what is the probability you win any of the prizes. I'm switching screens and I'm going to use my, like, you need to write something out. Unless you have a question, I'm not taking your hand. Question?
Yes, I have a question.
Okay, what's your question?
I have no idea if I did it right.
Well, did you use an area model?
I
I would advise area. They say or tree
found
diagram.
I found like the average amount that you would win.
That's not what we're asking. We're asking what is the probability that we win, period. Then we ask what's the expected value, but the first question is what is the probability we win? And once we set up the area model or tree diagram, we should be able to answer both questions. What's each value's probability of winning? Because it's not just an 8th chance of winning 100. So if you are setting up an 8th chance of winning 100, that's not true.
Wait, what?
We have an 8th chance of landing on 100, but that is not the chance of winning it.
Yeah. Wait, can you use the area model, I guess?
You know what? I'm going to make my life easy. Even though we don't need common denominators, forget it. I'm going to just use all 8s.
Yeah, same. I did that as well. I did that. Yeah, look. 1860. Because then I don't feel like writing the other stuff, so I'm just gonna write like square it.
I don't really care about any of the boxes for not winning. I just care about winning, right? What's my probability of winning a buck? Jacob?
9. Oh wait, just $1?
$1.
Okay. 9/64.
9/64. Richard, what's my probability of winning $5?
464.
4/64, so a little bit less. Right, which when I have everything in my probabilities as common denominators, all of these are comparable, right? Winning $1 is more than twice as likely as winning 5, even though the regions aren't that much different. My probability of winning $10, well, it's the same as winning $5. Which is actually great because my probability of winning 5 or 10 is 8/64, right? So that's pretty comparable. And then my probability of winning $100, no, we're multiplying. Be careful. 1/64. So the probability that I win anything, 18/64.
Which is pretty small.
The complement to that, the probability that we lose. What's the complement to 18 and my whole is 64?
That's big. What's the
What is it? 40 what?
46.
So what? We can only get the expected value after we've done this.
Yeah.
Okay, so hang on to
How
that
do we
question.
find that out?
I gave you the formula. You just weren't paying attention because
Yeah.
you were stuck in your head saying me.
I was trying to think, would this work? Would this work? Yes, it would work. So it's gonna work.
Or it doesn't.
Yes.
So here's one thing that's really hard as like a good math student and a smart person in general. It's hard to tell yourself that you're probably wrong.
Yeah.
But especially when you're trying new things, like proofwriting and those sort of things, like you should tell yourself, I'm most likely wrong. Where am I wrong? And then if you can't find anywhere that you're wrong, what's that? Yeah, and if you can't find the mistake, then you say, okay, maybe I'm right.
But you're still probably wrong.
I mean, until somebody verifies. That's why mathematicians put it to somebody else and they say verify this.
That logic just skipped over my head.
All right, so now for the expected value. And I really wish I had two different smart things open. We need to remember these, which I mean 9, 4, 4, and 1. So now for expected value, we are going to set up. Let's just start from the $1 again. So 9/64 times 1. Sorry, that one's a little weird. Plus 4/64 of 5. 4/64 of 10. And what was it? 1/64 of 100. Oh, I didn't put that.
2 and 41/64. That's a lot of money.
A lot of money.
Well, that's assuming that we're paying at least.
You're paying $3.
If you're paying $3 for this, you're losing.
You're gonna lose a lot of money.
If you're paying $1,
So 20, right? 40, 100, and 9. So altogether 169/64, which is like 2.
$1 yes, $2 yes, $3 no.
So by expected value, exactly what Saki said. Your ticket's $1, sure, play. You're probably gonna win. $2, yeah, you're still okay. $3, nah, you're likely gonna lose.
When it says is this game fair, does it mean that you're paying $3?
Well, okay, so fair is that really like dangerous word to talk about.
Because what does it mean?
What is fair?
What is fair, right? So if it's asking, does every outcome have equal chance? No. But if we just look at like, can we calculate this? Can we figure this? Like nothing's a mystery, right? We know the math. So like, I think what they're shooting for is like no, like not every region is the same and like whatever. But I mean, I don't know. If I know the math, I kind of argue that I think it is. I normally don't have to check the teacher guide, but I will check and see what they say about the whole is this game fair.
Is anything?
What is
What is justice?
What's that word?
Oh yeah, we get into trigonometry next week.
Mr. Hudson, what's that word where something looks like something but it's not that?
So, oh, yeah, here's the other thing. For a game to be fair, sorry, so here's their definition of like fair.
Not fair. Just write it down.
Your in equals your out.
No.
So if the ticket's $3 and you're only expected to win
Not a math
2 and
expert.
41/64, is it fair, like equaling out that really the only thing that makes you win or lose is chance? No, the game is set up for you to lose, well, like 30 something cents. They have it in here
I want
because that much of a dollar leaves you 36 cents deficit. So the whole "is this fair" is no. We have an expected deficit.
expected DEFCON 4.
Right, so if the game were fair, I'd have an expected outcome of nothing. What I put in, I expect to get out.
That's not really fair because then you're not doing anything.
No, but then it comes down to
The
chance.
definition.
Then it comes to chance.
Okay.
Fair would be chance determines everything. Not fair is I have strategically built this game that you lose.
But no,
What is
saying
someone's
fair,
person like this?
that logically
It's
doesn't
still
make
by,
sense.
it's still
Because
by
saying
chance.
fair,
There's
but
not-
chance wins you everything, but it's fair, doesn't make sense.
But what if someone
Because
makes
they're
a
not
game go to
stacking
court
the
just by
amount.
this?
So then again, isn't life fair?
No.
Yeah,
Well,
you
life
get
is fair
20.
because you
No,
come
we-
fly.
20 what?
Equal
Your
chance.
life is not
Chance.
equal.
I swear that says 6, but maybe it's my eyes.
No, you each have the same chance to be born by someone. But it's
Oh,
the
8?
chance.
Yeah, well, are you guys slightly off of us?
Yeah, it says 25.
26. Where are you reading 25?
On my
I'll find you with
schedule.
the new schedule.
Right here.
Schedule.
46.
But on my
26.
Right, it says 25.
I'm sorry.
We work on the test.
Oh, I'm sorry. Do we
Okay.
understand how to calculate expected outcome even though it's not like really realistic?
Yes.
Like, I mean, it is. It is what we expect to happen, but because it couldn't actually happen off one spin, this is just to compare for it. Now, if the game only costs $2, it's still not fair. But in the way of it's not fair bias towards the person playing and against the house, quote unquote.
Have you checked test revisions?
No.
Okay. That's not so
Actually, I might have. Give me a second. I'll check my folder. Yeah, I'm checking to make sure we don't need to go over anything else.
No, that thing you're fine.
The less you ask, the better.
So as long as you guys will promise me that you're going to ask me questions if any of the homework is a struggle, we can go ahead and just work on the test for the next 10 minutes.
Trust me, we'll ask you questions.
Okay. Let's start Monday with questions.
We will ask you